Hello everyone, welcome to the world of data structures. Our today's topic is searching in data structures. Here, today we are going to see two different searching techniques. One is linear search and another one is binary search. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today first we are going to see about the searching and the types of the searching methodologies. Then we will see about how it works. Then linear search algorithm, its example and the C function for the linear search methodologies. Next we have with us that is binary search technique. So same as the linear search, we are going to see about the binary search working, its algorithm, example and the C function for the binary search. So let's do not waste more time, start with the first technique, that is searching. So students, searching, that means when you want to search in a data structure a particular element, okay, when you want to find something, that technique is known as searching. If the element is present in the list, then it will give the location of the particular element and say yes, searching is successfully done. If element does not exist over there, then it says the searching operation is getting failed. Okay, so searching in data structure can be divided into two different parts. The first technique, which is known as linear search, and the second technique is known as binary search. So first we have the linear search, or we can say the sequential search. Students, the linear search method is also known as the sequential search methodology. Then the linear search and sequential search, it's a simple searching method. It is like a search in array or search in a list. So what you need to do over here, you just need to traverse the whole list, okay, and compare your key value, the value that you need to search in the list. Compare your key value with each and every element, and then if you get the answer, then write down yes, my answer is here, else there is no element found. So if it's match, then you can say like value search complete, else no value found. Okay, so here it is the first steps about the linear search methodologies. See, here we have in the linear search, we have the key element. Key is a variable which contains the element that we need to search out. Next, we have array of 0 to n minus 1. Okay, the index starts from the array from 0. That's why array from 0 to n minus 1. Okay, so what you need to do is, you need to search your key element in this particular array. Now, step number 1 starts from the first index of the array. You need to start from the first index of the array. Then compare your key element with the first element of the array. If it is found, then it's okay, else move ahead and go like that. You just need to increment your pointer over there, or you just need to compare your key value with the next value of the array until and unless you will get the value. So if the key is equal to a of I, then you can write return index. That means return I. I stands for the index of the location where the key element is exist. Else you can write return minus 1. Students, return minus 1, that shows there is no element. Okay, see here I am not returning the value, but I am returning the index of that particular value. Okay, so I can write minus 1. Because our index should not go on the minus 1. Fine. So if element is found, then you should return I, else return minus 1. Now, suppose this is my array. Okay, it goes like this. This is my array, and in this array we need to search something. Let's take out the example. See the algorithm, how it works. Procedure, binary search. Repeat. Procedure, linear search, where in as argument I am going to pass my array and the key value and the size of the array. So there are three different parameters, or the arguments are there. A stands for the array, key is the value which I need to find out in A, and n is the size of the array. So what are the steps? So step number 1, first I must be at 0. So for I is equal to 0, I less than n, I plus plus we can say. But this is algorithm or pseudo code, so I can write like this. If a of I is equal to my key, okay, then I should return I, and then I need to increment by I variable. Else this the end of the if, end of the for. Suppose if the element not found, then I should return -1. Okay. Now the next is, if this is my array, there are so many values are there. So how it works? Let's check it out with the example. So let's begin with the example with the linear search. Here our array is already given. We need to find out the key element 74. So here the array is given. We have the values like 85, 45, 78, 96, then 11, okay, then 25, 65, 74 and all that. What we need to find out over here? We need to find out the value, key value 74. Okay. So what is the first step? First step, you just need to compare the 74 with the first value of the array. So here it is. I'm just comparing 74 with the 85. Both are matched? No. So move ahead. Next, I'm going to compare 74 with my next value, that is 45. Again, no. Then I'm going to match 74 with 78. No. Next, 96. Next, 11. Next, 25. Next, 65. Next, 74. Yes, I got my value. I got my value at the 7th index. Okay, so it returns I is equal to 7. Okay, so you just get the idea. Yes, there is something that I get from the array. So my element is there. 74. Is 74 in the array? Yes, your answer must be yes, 74 is there in my list. Fine. So here, if you just see properly, students, if you can see here, 74 is situated at the 7th position of the array. That means I need to at least compare 8 different values from 0 index to 7. From 0 to 7, total 8 elements are there. So I need to compare 8 values. Suppose if my value is at 5th index, then I should do a 6 comparison. Suppose if my value is at 9th index, same like here. Okay, so I should compare total 10 elements over there. That means in linear search, you need to compare maximum n values. Okay, if there are 100 elements in the array, then you have to compare your key value with each and every element. Just imagine a situation or a worst case that if you have an element at the last index, then you have to do comparison for the n elements. Fine. That's why the worst case time complexity for the linear search algorithm is O of n, where for the 10 values you need to compare at least 10, for the 100 values you need to compare at least 100. That's why for the n value you are going to compare n elements. Fine. So that's the time complexity of the linear search. Now here we have the C function for the linear search. See, it is same as the algorithm. Okay, I'm just showing you in 2 or 3 examples like how can we convert the algorithm into C function. So here we have the integer because we are returning something. Okay, so integer linear search, integer array, integer n is the size, and integer key that we need to search out. Then I'm going to define the integer I for my for loop purpose. Okay, so it goes like this, that for I is equal to 0, I less than n, I plus plus. Okay, if a of I is matched with key, that means if a of I is equal to key, then we should return I. Okay, here it is I. Okay, don't see the capital, it's a small value. Fine. Okay, so return I. Do not need to write about the else. If your value is found, then your function control is already written from the if block only. If value is not there, then it goes down and it returns -1. So whenever you're calling this function, you just need to catch out the value from the function. Okay, and check it out. If the value is -1, that means value is not found. If value is rather than -1, like 78 for like 1, 2, 3, 4, 5, 6, whatever it is the positive index or 0 index, then we can say that the value is there in the list. Fine. Now let's take a look at the next method. Next method, students, we have binary search. See, binary search is an efficient searching method. Okay, here it is very much essential that your data must be in a sorted order. This is a precondition. Many of times in interview or in many of the programming questions, you may ask that what is the precondition for the binary search. So students, for the binary search, you must know that that element should be in a sorted order. That means in ascending order. Fine. So here it is. Steps to convert for the binary search. First, key element is given to you that you need to search it out. Then a of 0 to n minus 1 is also there. Okay, that means array in which we need to search. And next, students, we have a of m. A of m means mid element. Here m shows the middle index of your array. Fine. So a of m, that means element, and m means index. Okay. So here it is. See, step number 1. What I'm going to do is, first you just need to compare your key value with the middle element of the array. Okay. So here, if k is equal to a of m, that means your key is your middle element, then you can directly say that element is found. But if it's not like that, second case is if key is less than a of m. If key is less than a of m, that means you need to search out in the left side of the array. Okay. And the third part is if the key is greater than a of m. If key is greater than a of m, then you need to search in the right part of the array. See, here we are going to divide our whole array into two different parts from the middle element. Okay. If this is my array, this is my middle element, this part is now known as left array, this part is known as right array. Fine. Okay. So here it is. Such like this, you have an array. So suppose here the total number of indexes are 0 to n. Okay, that means 0 to n minus 1, that means 0 to 9. So our middle element will become 0 plus 9 by 2, that is 4.5, so approximate 5. So m must be 5. Okay, so the left side of the part, like 0 to 4 is known as left part, and 6 to 9 is known as right part of m. Fine. So next we have the binary search algorithm. So how the binary search algorithm works? See, same as the linear search, here we have in our argument, we have only that array and the key. Okay, so here it is. First, see, here you have two different indexes. One is low. Low stands for the index of the starting of the array. Okay, so low in the start position, it must be at 0. And high, that means the last index of the array. So the high must be at n minus 1. So always you remember, you need to initialize low at 0 and high at n minus 1. Fine. So until and unless your low is less than high, you need to follow the below steps. Okay. So the condition for the while is while low less than high, you need to do first step number 1. First, find out the middle element. So middle index is low plus high by 2. Next you have if key is equal to a of m. That means if your element is there, then you can write return m. Okay, if we found the element, we are just returning the index of that particular middle element. Else if key is less than a of m. Else if key is less than a of m, then what to do? See students, if the key is less than a of m, then you need to move high to m minus 1. We need to move high is equal to m minus 1 because we need to search out in the left part. Okay, just imagine a situation, if this is your low, this is your mid, this is your high, then if your key is less than m, that means you need to find out in left part. Okay, that's why you need to move high to m minus 1. Else, if your key is greater than a of m, if your key is greater than a of m, then you need to move low to m plus 1. Fine. So this is the algorithm, okay, that we need to show. If element is no there, then at last it returns minus 1. Okay. So let's understand the binary search algorithm with the example. So here we have the data like 10, 20, 30, 40, 50, 60, 70. It is already in the sorted order. Fine. So let's begin. First we have the array like this, from the 0 to 6 indexes are there. Okay. So in the first time, I'm just highlighting each and every element for you. So this 10, 20, 30, 40, 50 and 60. Okay. We need to search in this whole array. We need to search in this whole array. That's why I'm highlighting such elements. Okay. we need to search in whole array. Fine. So first, at the very first position, low must be at 0, high must be at n minus 1. Fine. That means high must be at 6, low must be at 0. And which key we need to find out? So our key element that we need to find out is 50. Fine. Okay. So let's begin. See, here the low is at 0, high is at 6. Fine. So what is the value of your m? M becomes low plus high by 2. That means 0 plus 6 by 2. That means 3. Okay. So your m must be at 40. That means third index. So here it is. Low is at 0. High, that means 7 minus 1 is equal to 6. So students, let's calculate first m. See, on the right side of the image, I'm just writing down the algorithm so you will get the better idea. Okay. So here it is. First, m is equal to 0 plus 6 by 2, that equal to 3. Fine. So we have m, we have high, we have low. So now just check out your key value comparison with m. Now trace the algorithm. First, the condition is low is less than high. Okay. So here the low is at 0, high is 6, condition satisfied. So go inside the function. M is equal to low plus high by 2, that becomes 3. Now search your key value. Key is equal to a of m. See students, here key is equal to a of m. Is that so? No. Check it out. M becomes 3. That means key is equal to a of m. Key is 50. A of m is 40. Both are same. So write down no. So for condition getting false. Next we have check a of m is equal to key. No. Okay. Next we have students check key is less than a of m. Just check it out. Key is less than a of m. No. Key is less than a of m. No. Fine. So next move ahead. Check it out. Key is greater than a of m. Key is greater than a of m. Yes. Because the key value is 50 and a of m is 40. So 50 is greater than 40. Yes. So here what you need to do is you need to move your low to m plus 1. Okay. See, your low is right now 0, m is 3. That's why your low becomes 3 plus 1. That means 4. High is as it is. So high is at 6, low is at 4. So next task is to search in the right array. As your key value is greater than a of m, you need to search in the right array. See students, our right array contains the values like 50, 60, 70. So now my new low is at 4, high is at 6. And now what is the value of my m? So let's calculate it. Here low is at 4, high is at 6. That means 6 plus 4 by 2. 10 by 2 becomes 5. So my m element is at 5. Okay. So now just begin the search. Okay. So here we have first check out a of m is equal to key. So no, it's not key. Next check out key is less than a of m. 50 is less than 60. Yes or no? 50 is less than 60. Yes. Okay. So you get your answer. That means 50 is less than 60. So here you need to search in the left part. Okay. So out of 50, 60, 70. Out of 50, 60, 70. You need to search in the left of the m. Okay. That's why you need to move your high. So here your new high becomes m minus 1. M minus 1. M is 5. M is 5. Your high is at 6. So now your new high becomes m minus 1. That means 5 minus 1. So here it is. High becomes 4. Low is already at 4. So now you will have your new high and new low at the same position, that is 4. So now let's begin. See, right now students, your low, high both are at 4th position. So here it is. Low plus high by 2, that means 4 plus 4 by 2, that means 4. So just check it out. First here check a of m is equal to key. 50 is equal to 50. So say yes sir. 50 we found. That means we found our element. Okay. So have you ever seen that how many comparisons we did till now? That means how many times we just call our function. Okay, like 3 times. First we just compare with the whole array. then the right part of the array, and then with the actual value. So out of these 7 values, you are just start comparison with only 3 times. You are comparing the value only 3 times. So in linear search, if you have 100 values, then you need to compare 100 times. If you have n values, then you need to compare n times. But in binary search, if you have 7 values, then you need to search at least 3 times, minimum 3 times. Okay, so it saves your time also. That's why here we have 50 value, and we can say that in 3 iterations, we just comparison 3 times. Okay, so in 3 iterations we get values. So 7 value, for the 7 value maximum you need to do 3 iterations or 3 comparisons. So for n value students, the time complexity of the binary search algorithm is O of log n base 2. Okay, so if you have 16 values, then O of log 16 base 2, that becomes 4. So for the 16 values, you just need to compare only 4 times. So for the 64 values, you just need to compare maximum 6 times. This is the benefit of binary search algorithm, where your time complexity reduces a lot. In linear search, we are comparing the values for the n times, but in binary search, we are comparing the values O of log n base 2 times. Fine. That's why this binary searching method is very much useful and efficient for all of us. Okay. But the precondition is that only your data must be in a sorted order. Your data must be in sorted order. So that's it for today's lecture, students. Thank you so much.